Today we're going to look at 8.3 trig functions and relationships, and we're going to jump right into this algebra review. What I'd like you to do first is simplify and choose your answer for number 1. A common mistake on number 1 is we tend to bring this squared in without actually foiling out the two binomials. So you want to be careful not to make that mistake. The answer to this first problem should be 4x squared minus 12xy and plus 9y squared. So just being really careful to distribute, the two binomials. In number 2, go ahead and choose your answer. And this is kind of a funny one. This actually is as simple as possible. The reason I have this on here is because we tend to incorrectly think we can distribute the radical. The reason we can't distribute the radical is the same reason we can't distribute the squared in number 1. It's because of the subtraction sign. So if it's all a product, then you could break up the radical, that'd be fine. But when you have 25x squared minus 9, then you cannot just square root each piece. So be really careful about that. And then on number 3, the only thing we can do here is rationalize this. So you're going to multiply top and bottom by root 1 minus x and simplify. Go ahead and choose your answer. And not much you can do here. Your final answer is going to be 2x plus 5 with the root 1 minus x. The denominator comes out to a plain basic 1 minus x. Just be careful to make sure you have those parentheses in front of the 2x plus 5. Now what I'd like to do is go through a problem with you that'll kind of show this co-function identity relationship. We're going to look at this right triangle. We've got a right angle here at the bottom right. And let's address a couple things, starting with sine of theta. Here's theta. So sine is opposite, which is A, over hypotenuse, which is C. And then in 2, they have cosine of phi. Cosine of phi is over here. Cosine would be adjacent, which is A, over hypotenuse, which is C. So what we should see is that those two are the same. Sine of theta and cos of phi are going to be the same because they're both A over C. Well, what else do we know? We also know that phi is going to be pi over 2 minus theta, because whatever phi is, let's say it was like 40 degrees, we know that those two add up to 90, so then theta would have to be 50 degrees. And how did I figure that out? Well, I just did 90 minus 40 or whatever. I'm going to keep everything in radians for the purpose of our identity and call it pi over 2 minus theta. Let's fix that theta. There we go. Okay. So since 1 and 2 are the same, I can say that sine of theta and cos of phi are the same. Sine of theta is equal to cos of phi. But then what I can do is I can rewrite phi in terms of theta using part 3. So instead of writing cosine of phi, I can write cosine of pi over 2 minus theta. And this brings us to another identity. And this is one of our co-function identities. There are actually 6 of them. So what I'd like to do is list them all with you here. The first one is what we is kind of the reverse of what we had actually. It's sine of pi over 2 minus x is equal to cos of x. The second one is what we just saw above. Cosine of pi over 2 minus x is equal to sine of x. Then I have one with tan and cotan. Tangent of pi over 2 minus x is equal to cotan of x. Make sure you're writing these all down carefully and correctly. Then we have some with the reciprocals. Cosecant of pi over 2 minus x is equal to secant. Secant of pi over 2 minus x is equal to cosecant. And one more, the very last one, is the cotan-tan flip. So cotan of pi over 2 minus x is also the same as tan of x. Pause this video if need be, write all those down, add them to your identity sheet. And then what I'd like you to do is try example 2. Example 2 wants you to use an even-odd identity from before and a co-function identity from above to rewrite this as a single sinusoidal function. Go ahead and try that and put your answer in the Edpuzzle. And what should have happened in this problem is your sine of negative t became a negative sine of t, and then your cosine of pi over 2 minus t, using the identities above, became a sine of t. So you ended up with 2 sine of t plus 3 sine of t, and then plus 4 sine of t. So altogether, the function at the end becomes 9 times sine of t. Now, moving on to the next page, we have example 3. And we've done problems like this before, but we're going to use identities to help us solve this one. So we're told that theta is a quadrant 2 angle. So what I'm going to do first and foremost is set up a triangle in quadrant 2. And they tell us that sine of theta is 1 over 3. Now, we've done this before using a visual graphing method. What we're going to do instead of solving it that way, like we've done in the past, is we are going to this time instead use identities to help us. So the first identity I'll use is the reciprocal identity. If sine is 1/3, cosecant is 3. That's a nice, easy one. Done. Then what I'll probably do is use my Pythagorean identity. I know that sine squared plus cos squared is equal to 1. And I know that sine is 1/3. So if I take 1/3 and I plug it in, I can go ahead and solve for cosine. Go ahead and finish this and choose the cosine answer that works. You end up getting that cosine squared is equal to 8/9. So your cosine value should come out to either positive or negative 2√2 over 3. So that's the value, but how do we know if it's positive or negative? Remember, we are in quadrant 2. So based on that quadrant, I choose the negative answer. So my cosine value is negative 2√2 over 3. Just be really careful that you're paying attention to quadrants all the time. Once you have cosine, then you can find secant by reciprocating that. I'm going to skip the work here and give you the answer. Please pause this video if you need to make sure you can work it out on your own and rationalize and get to this solution. I'd like to do one more identity. I think what I'll do for the last ones, I now have sine and cosine, secant and cosecant. The last ones are going to be tangent and cotangent. Instead of using a Pythagorean or something like that, I think what I'll probably do is just use the tangent identity that says that tangent is sine over cosine. And then I can use the direct values that I already found. Sine is 1/3 over cosine is negative 2√2 thirds. If you multiply this fraction by 3 over 3, that is going to cancel denominators. So that will leave you with 1 over negative 2√2. You're going to also rationalize that, and you will get an answer of negative √2 over 4. To get the cotangent value, you are just going to flip that around. Again, pause this video if you need, work it out for yourself, and make sure you can get to this answer there. Now, example 4 is exactly the same problem, but what we're going to do, again, is use identities, not the triangle. So let's go ahead and try it. It's a little harder because it doesn't have all numbers. It has an X in it. But other than that, the work is the same. Again, the first identity I always like to use is just the reciprocal identity. If you're given cosecant, then you automatically know what sine is. So that's always a really good place to start. Now let's go ahead and use identities from there. I know that sine squared plus cosine squared is equal to 1. We've got a little bit more algebraic work here. I'm going to subtract. So I have 1 minus 2 over x squared became 4 over x squared. And what you're going to want to do is put those together. So treat this 1 as an x squared over x squared. So when you put that all together, you get x squared minus 4 all over x squared. This is why I went through some of that algebra simplifying to make sure we're comfortable with this. When you square root both sides, you get either positive or negative. We're going to choose negative because we're again in quadrant 2. The top you cannot simplify. You can only leave it in the radical, but the denominator you can. So that should be your final value for cosine. For secant, you are just going to flip it. And when you flip it, you're going to make sure you also rationalize it. Again, you might want to pause this video to try it on your own. But the answer that you should get, I'm putting up on screen for you. And then the very last part of this is finding tangent and cotangent. To find tangent and cotangent, what I would do is put sine over cosine and then cosine over sine. So your answers for that, I'm just going to give you the answers here. Make sure you're trying them on your own. The tangent should come out to 2 over negative radical x squared minus 4, but then make sure you rationalize. So it actually becomes negative 2 root x squared minus 4 all over regular x squared minus 4. If you want to flip cotangent from there before you rationalize, that might be a little easier. And it should just be the negative radical over 2. So that's kind of nice. If you had that in your work anyway, you can maybe catch that answer a little bit earlier. Now, the last part of today's Ed Puzzle is doing some simplifying. I like to give you guys time to practice this, but what I'll do is do a couple of these with you. Let's go ahead and start with part A. If I replace the denominators with their reciprocal identities, so I'm leaving the sine and cosine, but I'm rewriting the cosecant and secant as 1 over sine and 1 over cosine. When I simplify sine over 1 over sine, if you're not comfortable with that fraction, sine, you can think of it as divided by 1 over sine, which really becomes sine times sine. When you divide by a reciprocal, it's the same as multiplying. So this becomes a sine squared, and this becomes a cosine squared. Well, that's an identity. That gives you just a 1. Go ahead and try part B on your own and put your answer in the Ed Puzzle. In part B, your final answer should have come out to a positive 1. I'm not going to walk all the way through this, but a hint, maybe try starting tan squared as sine squared over cos squared. Either getting common denominators or even reciprocating those to be cosecant squared minus cotan squared. There's a couple different ways to get through this. But if you have questions, make sure you ask next class. The final answer should be a 1. So if you're getting there, you are on the right track. On part C, I'll let you guys do this one as well. Use your even odd identities to replace sine of negative x and cos of negative x. That should help a lot to get you started. And your final answer here should be 0. And I'll work through this last one with you. This last one, what I think I probably want to do on the top is factor out a sine squared, because I see that both of these terms have a sine squared in it. That leaves me with a sine squared minus 1 all over secant. Well, the good thing is I know something about sine squared minus 1. I know that sine squared plus cos squared is equal to 1. So if I just manipulate this, sine squared minus 1, that's going to equal negative cos squared. So we can replace that with a negative cos squared. So using my Pythagorean identity, but I have to manipulate it to get it in there. So what I have now is a negative sine squared and cos squared all on top. The denominator, secant, you might want to change it to a 1 over cosine, which really means it's another cosine on the top. So at the end here, you get negative sine squared and a cos cubed. And that's your final answer. There is nothing else you can do to simplify that.